This is an example of sedimentation basin design at a water treatment facility. So in designing a sedimentation basin or a clarifier, which is also called, you might do some bench scale tests that might tell us more about the type of particles that are coming into the water treatment facility. And so in this case, they've done that, and those tests revealed that the settling velocity for typical silt particles for, in this case, Alvarado Water Treatment Plant, that's their typical settling velocity, 38 times 10 to the negative fifth meters per second. And now you're to design a clarifier to remove those types of particles from the water that's coming into the plant. Okay, the residence time in the clarifier needs to be 2.6 hours to achieve the proper settling. And the plant needs to treat 3 million gallons per day to meet the demands by the residents of the area. So what's the volume and the planned area going to be? You're going to design this, and this is what you need to know. How much space is it going to take? What volume is it going to treat? And let's assume the depth is 3.5 meters, which is a reasonable size for a settling basin. Okay, so to determine the volume is just time times flow rate, right? And then you can get the volume. Time cancels out. Okay, so volume is the residence time times the flow rate. We know that the flow rate is 3 million gallons per day. The residence time, we're going to need 2.6 hours, and then all the rest is just conversions. We get a volume of 1,230 cubic meters, which is fairly large. This will probably be a large circular clarifier. And then if the height is 3.5 meters, the planned area is just going to be the volume divided by the height, or 351.5 meters squared. So pretty simple problem there, just using this relationship here for residence time and flow rate. Okay, so it turns out in this problem the settling velocity was not needed, but we can use the settling velocity from the tests to check if our residence time is correct, and if the residence time given is correct. And we can see that 3.5 meters divided by the 38 times 10 to the negative fifth meters per second, that ends up being 9,226 seconds, which is the same as 2.6 hours.